Hello and welcome to this video. So in last two videos, wait. So first of all, welcome to this video and special welcome to those who are new to the channel. If you are new to the channel, make sure that you subscribe to the channel and press the bell icon so that you can get notification about new and upcoming videos on the channel. And in this video, we will study the shortest path algorithm of Dijkstra using adjacency list. So we have earlier in last two videos we have covered the heap, max heap and min heap, and before that we did the adjacency list shortest path for Dijkstra's algorithm. So in this video we will look at adjacency list implementation. So it is essential that you have watched the last three videos before you proceed further, and there is a adjacency list representation of graph earlier before this. So make sure you watch all the videos of the graph related which I have uploaded on YouTube earlier. So go through the playlist of data structure and algorithms using C and locate the graph videos. And if you are continuing, then yeah, it's fine. So there is not much to be discussed here because the algorithm we have already discussed, and the crux of algorithm is already discussed, not the exact one which we are going to do in this. So let's get started on this. So as always, I have split this into three parts. One is main.c, the driver program, then our header, and then the core logic of the program. So in the main program, we create a graph of 7. Okay, we have two distance and previous arrays, and start is equal to 0. And we create this graph by calling the join function. And the final shortest path is done by Dijkstra's function, which is defined in the main logic. And then we finally print from start the cost to all the other nodes. So start is from 0. So you can change the start from here. Okay, you can control from here. So now we look at the header file. We have our node which contains destination and cost, and next to this, to create the adjacency list, we have our graph node which has number of vertices and the adjacency list. We have heap, which is a min heap because we need a priority queue as we discussed 3 videos ago. And then we have functions for heap. These are the functions for heap. And we have functions for graph, create graph, join, and Dijkstra. So we will not go through the heap implementation because I have already explained this. So create heap, heap down, heap up, push, pop, empty, and top we will not discuss. We have already seen how we create graph. So we allocate the memory for graph, we assign the n to num vertices, we create our adjacency list, we set the initial pointer to null for adjacency list, and yeah, when we join, we receive the graph pointer, we receive source and destination and cost, we allocate for node, and using our min heap logic, we create this adjacency list. We set the node next to adjacency list src, and then we set adjacency list src to node. So consider that, let me try to explain a bit. Initially it is null adjacency list. So when a new node is coming, so let's call that 1. So 1 will come before null and it will point to null. Then if 2 comes, then 2 will come before 1 and it will point to 1. So it is basically a linked list insertion at the beginning. The reason for doing this is O1 operation, and if you append at the end, then it is ON operation. So I chose to insert at the beginning. So once we have this, we created the edges here. What we do is we implement our Dijkstra algorithm. We set the distance I to int max and previous I to -1. So both are undefined in this case. And distance of start from itself is 0. And here we use our heap. We create the heap and we push all the vertices on the heap. And while the heap is not empty, it is essentially a priority queue. Okay. So in the priority queue, since it's a min heap, the smallest node will always be at the top. we get the top node and we iterate over the adjacency list, and this is the crux of the logic of Dijkstra algorithm, which finds the distance and previous and updates it in the array. And once it is done, we print this over here. So it's pretty simple code if you have followed our earlier videos. So let's see this in action. So let's compile this. I have already compiled and run, and so we run this. So I'll let you verify this cost from the graph. What is sort of homework for you is that you take these functions and plot the graph, and then try to find the shortest path from your pen and paper diagram, and then you execute this and try to see how it works out, whether this output matches the manual calculation or not. For example, 0 to 1, if we see, I'll try to go for some nodes. 0 to 1 cost is 3. Okay, 0 to 2 cost is 5. So if you see, we have a direct path from 0 to 2, that is 6. But if we go from 0 to 1, it is 3, and from 1 to 2, the cost is 2. So 3 plus 2 is 5. So direct path is not the shortest path. So this way you can iterate through this graph and see how it works. So I think that covers what we have studied earlier, and this is how you implement the shortest path algorithm for Dijkstra using adjacency list. And I'll end this video. I hope that you have found this video useful and informative. If so, please like the video, share as much as you want, and let me know in comments what other topics you want to discuss in data structure and algorithms, and I will try to cover those. So we will have many more videos. We have still to deal with cyclic graph where there is a cycle. How do we detect the cycle? We have Floyd-Bellman algorithm or something like that. I don't remember exactly. So we will see all that in upcoming video. And thanks a lot for watching. Happy programming.